So yeah, I'm going to be talking about Icinga 2 and Ansible. But first, yeah, who am I? I'm self-employed, I'm from Antwerp, so not that far from here. I like to do enterprise Linux. You have a whole bunch of them. I like to keep things secure. So people who answered that they disable as a Linux, let me know afterwards, I'll kill you then quietly. Yeah, I'm involved with a lot of virtualization, which involves a lot of automation. My preferred automation is Ansible. I know Puppet. I do a little bit of Salt, even though my knowledge of Salt is a little bit older. And I do a lot of hardware and software, both of the stuff. So first something about monitoring, then about automation, then about Icinga 2. I've divided Icinga 2 in the master, so that's the nodes that run it, and then the clients is, in my case, the example I'll be giving is NRPE, but it's similar if you're using NSCA. And then a conclusion, which is one slide. So in the beginning, monitoring sucked because, yeah, I heard some stories that people had like 10,000 services in one file. And then when you edit that file, then you had a lot of problems. You couldn't add dynamically. And traditionally, installing software was not that easy, and adding nodes was not that easy. Meanwhile, we have solved that. Icinga 2 is now quite modular. It's quite dynamic, so you don't need to do all of those stuff that we had to do before. In the meanwhile, there are some other issues which are not monitoring necessarily, but which involve monitoring in a greater scheme. So I'll go over some of the some of the products I used. Nagios, we all know that one. It was good in the beginning if you had a small number of hosts and services. If you ran more than around 500, we heard stories this morning that it could take up to 15 minutes to load the configuration. I never had to wait 15 minutes, but 5 to 10 minutes was quite normal. Xenos, well, if you got it installed, yeah, you had a book next to you, and you did that one time, and then you had the machine running, and you left it alone, because if you changed anything, then you were basically screwed, because management would come and kill you. Zabbix, it's a quite good one. The main problem with it is it's very clicky, very GUI. So for those system admins who like a clicky GUI, they're mostly referred to as the Windows people. They like this. They enjoy clicking and adding host one by one. It's a little bit difficult. Or you could do database injections, which are also not always that easy, because there were dependencies that were required. Ganglia. I still come across quite a lot of people using Ganglia. It's quite static, so the RRDs that were shown this morning, the white ones, are the ones you get static, not a lot of extra information. It was good once upon a time. I don't think it's that good today. You have Icinga, so I'm talking about the one, which was a fork of Nagios, which had a better web interface, which was a big improvement in speed and a lot of other factors. You have OpsView, which is also a fork of Nagios, also quite popular with certain government institutes. I don't see any benefit in it, to be honest. Schinken, it's a Python version of Nagios, so it was a rewrite in Python, which is my preferred language. So I tried it. It works very well with the 50 hosts we used for testing. We tried to move to pre-production and ran out of memory. I had given the machine 16 gig of RAM, so I suspected it should be enough, but still running out of memory. So it's good if you run smaller install bases. Once you grow, it doesn't scale. Then Icinga 2. So when Schinken failed, Bern told me that Icinga 2 was being developed. At that time, it was still quite infant. So I tried it out. It was already better than Schinken was at that time. So I moved to that. It's distributed. It's scalable. We have about 3,000 nodes in it. On average, each node has about 10 services in it. So, and it works with 4 gigs of RAM. So, automation, yeah. I use Ansible, like I said, so I'll explain Ansible shortly. But like Chris said, today you should have all your infrastructure as code or as some form of management system in it. Preferably as code, because that you can reproduce, you can test, you can do a lot of other stuff with it. Ansible is a very small tool. It's very good at orchestration. It can do configuration management, even though it's not the best at it. And it does a lot of deployment stuff. So Ansible is Python 2 based, so no 3 for the moment. There is work to have the client side at least run 3. The management node needs 2. It's server based, so that means you have my laptop in this case, which is the master node, and from my laptop I will push stuff to other machines. It's agentless, and you see the little mark, so you need to have SSH or WinRM if you're a Windows user, which it will connect to, and then it will run all the operations. So for the node that you're going to manage, you should have Python 2. It's not a requirement, but it's preferred. For WinRM, you need PowerShell 3, I think. I don't remember now by heart. So yeah, it has something called accelerated mode, where it will connect one time over SSH and then create a pipe. In that pipe, it will run commands a little bit quicker. Host files are in, host information is in flat files. So you have one master flat file or a script which will get all the information in JSON and use that. So if you have your current CMDB, we can actually reuse that by writing a small script which Ansible will hook into. There are scripts for Foreman in the meanwhile, for most of the larger CMDBs even. So what it does is it takes a task, a module, and executes that on the node that you want to do stuff on. So let's say if you want to execute the module user, it will actually transfer the Python module to the other side, will execute that Python script with a certain variables, and it will do stuff. And then it gets information back in JSON and outputs that on your screen. Those tasks combined create a playbook which are written in YAML or JSON. So most of the playbooks can be read by normal humans. If you have auditors looking at that and they can understand them, shoot them. Roles are abstract playbooks. So the concept of a role is, theoretically, a role should be interchangeable. So if I write a role, tomorrow you should be able to use that. Obviously, it's very easily said, but to have a really abstract role, you need to write your role properly, because otherwise you're going to have a lot of hook-ins. You're always going to have variables which need to be defined. So it's a combination of the task, the variables, and handlers. Handlers are tasks that are only run when a specific condition is met. We'll see that later in an example. Templates are in Jinja 2, and as I explained, it works where Python 2 works. It can run, so it can configure your Cisco routers, even though it doesn't have Python, because it drops down to shell and runs the Cisco commands, or whatever device you have that doesn't have Python on it. How does it work internally? So the upper square is actually your management node, and then you connect to whichever machines you want to. So you can have application server, database servers, your other hosts like a load balancer or a monitoring system. It uses SSH. The 0MQ has been depreciated. They have their own protocol now. You can do local executes, which actually run on the laptop, so you can prepare stuff and then send it to the opposite side. That's the normal method of connecting. And then you have something called delegation, which is that in place of to the nodes that you want to connect to, so let's say you're connecting to all your web servers, you're actually going to connect first to the monitoring and take them out or put them in maintenance mode, and then run your updates and put them back. You can do that with the load balancers. You can do that with all type of other machines that you have to call certain functions on one time. So how does a host file look? It's an ini format or a script. If it's a script, it needs to give back JSON. If it's an ini format, you basically have the squares which give up the groups, and then the names, in this case, hypervisor 0, 1, 2, and 3, and then the virtual machines, which is a group with VM 0, 1, and 2, and 3. From this, it will figure out what to connect to. So, or it drops down to SSH, if you have it configured on SSH level, or you have to configure it per host in a separate file. And the separate file is YAML-based. Well, it's JSON-based. YAML being a subset of JSON, you can mix them through each other. So the 3 lines here indicate that it's a JSON file, and then in this case it gives me which distribution to install, what architecture, and so on and so on. Yeah, a few examples here. This is a virtual machine. So in my case, the virtual machines are defined in the files itself. And at the bottom, you have the NRPE connection that it will create. And in that, I create a zone. So the zone will actually be used in the NRPE declaration on the Icinga nodes. In this case, we are basically going to set up a machine with a specific number of disks, partition layout, and networking. Yeah, networking. Yeah, another example of a more common one. Then once you have your inventory based in all these files, you can actually execute and install the VMs so that we can add them to Icinga. So the installer basically, well, in this case, it sets a lot of variables so that you can start the installation. In this case, the installation will be a CentOS-based machine, which will install a simple minimum install. At the end, because the machine doesn't exist at this point, we actually have to take all the facts off, which are the variables that come from the machine itself. And at the end, we need to run the fact gathering manually. That's the subsection of installing the CentOS machine itself, which basically just executes a libvirt installer, which drops down to an installer, to a text-based installer, and will install your virtual machine within whatever time. Most of my installations take about 3 to 4 minutes, depending on how far you're from your mirror. I have local mirrors, so it goes quite quickly. If you're pulling from public mirrors, it can take a little bit longer. These are the variables, so that's why it's still the private mirror listed here. But you can put a public mirror there, and it will basically pull or do a kickstart installation. If you prefer Debian, there are also pre-seed files I've written, which will install a Debian or an Ubuntu machine. Any questions till now? Yeah?
Is it possible to increase the font size? Some of the configuration files were not very readable.
I'll open them separately, because the font to rebuild will take some time. So that's how the machine gets built. At this point, we have a virtual machine, and now we want to add it to Icinga. Well, first, we want to now create the Icinga master. So in this case, what it's doing, it will check which is the master node, which we will install Icinga on, and the Icinga web on. It will then, if it is a master, do the installation. If it's a zone master, it will do a different type of installation, because zones have to be linked to well, to the main master. And afterwards, it will basically check everything and set all the details right. Yeah, this is basically, it doesn't come on the screen, but it's the full playbook of how it is. Can I? Yeah, I'm already here. So this is how it would look. So it will do a yum install with all these packages. So in this case, we're installing the Icinga packages. In my case, I have a Postgres database. So it will install the IDO for Postgres. It will install Carbon and Whisper. So I have Graphite. The system I now have doesn't have Grafana yet in it. I still need to make some adjustments for that. It will install all the plugins for NRPE. It will then copy the templated files. So those are the files that are with your configuration. It gets these configuration from variables or set in the host or set at the level of the group. So it will actually check the host, the group, and eventually the role for all the variables it can find. If a variable cannot be found, you get a nice error, undefined variable. It will then do the rest of the installation, which is basically setting all the files correctly. A template file is basically, is basically just a text file with variable. Well, this one doesn't have variables in it. Which one does? Nope. Zones has, which is basically Jinja 2. Here you see a for loop, and it will take all those variables and fill them in. It does a similar setup for the zone master. The zone master is basically like a proxy. So if you have nodes which are not connected directly to your main master, you can actually have machines in between which monitor all the machines within that zone. In my case, the Graphite stuff is only on the central machine. There's no Graphite on the zone masters, given that they are normally smaller in size. So here's an example of the Jinja stuff, which does a for loop over this. And then if it is a subzone, it will create a parent. And then you can actually create a parent of a parent and children and grandchildren and create complex zones from there. In my case, I have NRPE, which is going to do the checks on the host itself. So when it basically will check, well, in this example, I only have a Red Hat and a FreeBSD. It will check which one it is and then execute the commands accordingly. It will then contact the Icinga main master, which in my case is Trivikrama, and it will update the host file. Then you see the notify. So if that host file gets written and there is an actually new file that gets written on the file system, it will get it changed. If you deploy this 10 times, then on the after the first time, you will get here a non-changed state, and the notify is then not executed. So the notify only gets executed when the action changes. And the reload Icinga is basically the handler which will do a reload of Icinga. It will do the installation for Red Hat with Yum. It will install all the necessary packages, will install the main NRPE configuration, so from where we can connect to, and what we are going to monitor. In this case, it's a simple VM, so there's nothing special. You're going to monitor the users, the disks, the load, and so on. And then you're going to start the NRPE daemon and make sure that it's enabled so that it starts at reboot also. most of the NRPE stuff is quite simple. It's basically just checking the load and giving the information back. This is the only one which is a little bit more complicated because it will filter out the mount points. So none of the fuse mount points, none of the NFS mount points we are interested in. We're only interested in local disks if there are any on that machine. So this code block will actually loop through all the mount points and will check whether that is a local mount point and then add it to the check of NRPE. This is a simple one. It just basically fills in one variable where the NRPE check command is. For IOStat, it's the same. It will just loop over all the disks that it can find. And disks is anyway a physical disk, whether it's rotational or not rotational. We just want to get the statistics of the I/O from there. The host file is a little bit bigger. I'll open that here. No, that's an NRPE. Yep. So here it will basically create the object. It will fill in all the names and the addresses. Depending if it's a guest or a host, it will define a parent. And then it will go through all the services that we want to define for that host. This file gets written to the Icinga main master, which will distribute that to to the specific zone that it belongs to. So if a host belongs to 2 zones, it will actually do the redistribution for you at that point. So to run a demo, okay. This, well, yeah, I was going to. So this command is Ansible playbook. It will run the playbook Icinga 2, which is basically going to execute the role Icinga 2. And the role is defined in the tasks main task. No, this one, the main. So in here, it will execute this and then go to the master and the zone master according to what it's supposed to do. Yeah, depending on your output of Ansible, you get nice ones or a little bit less nicer ones. So here you see that it's installed. Well, I prepared the demo because I wasn't sure if I had good internet or not. So you see that it's changed the zone file. It will. It hasn't changed the Icinga main configuration. It's now activating all the rest of the stuff. So it will install Icinga completely. It will configure Graphite. It will set up the Postgres database and set all the other variables accordingly. Any questions while this finishes? Yep. The last slide will tell you exactly where. Yeah, the purple stuff is things which I wrote a year ago, which I still need to change because in the meanwhile, Ansible, this was written for Ansible 1. Now we are at Ansible 2, so there are some changes which has been depreciated, which I still need to change. So at this point, we have Icinga running. Let's see if I can get it up. Firefox. No, I need to. Okay. So yeah, like I said, I pre-configured it. Well, I made sure that it's working given that I wasn't sure it would run that quickly. So at this moment, I have Icinga running. I logged in with the default password. It's a local system, so it's not much configured on it. And now we can add hosts on it. No. Where did my mouse go? Okay. So we can actually run the tasks for NRPE and run it on that specific node itself, so it will add itself to the Icinga machine. So it installs all the dependencies. Because it was all installed by the master, it's going to tell you that it's all okay already. It's going to configure all the commands for you. And then it's going to start the daemon, set the host file on the host system, and reload Icinga for you. And now if we go and see here, nope, it hasn't added it. Okay. Let's see why. Nope. It's well, normally it should come up there. For some reason, it's not giving any errors, and it's not telling me why. Ah, yeah, okay. The Postgres database hasn't been reloaded yet. It's running on a slow machine, so let's see if I can manually restart it. Nope. Well, yeah. Well, for some reason it refuses to reload. I was also changing code, so most probably something I did. So normally the transformation from Icinga to Icinga 2 would mean that with this type of a role-based, you could actually migrate whole your install based if it is in a CMDB already. It will set up all the stuff for you. The NRPE that I wrote is, of course, quite simplistic. It doesn't do any of the advanced Apache or your application server. For that, you need to write or add specific roles separately. For the rest, it normally works quite well. So yeah, the three roles which are finished are the VM installer, the Icinga 2 which installs the main master, and the NRPE. The NSCA ng doesn't contain any files yet, I think. I still need to update that on GitHub. Any questions? Yeah?
Do you have any plans to extend this playbook to roll out Icinga 2 agents to the servers and add them to the master?
What do you mean by agents?
Icinga 2 as an agent?
Icinga 2 as an agent. Sorry? So at the moment it can, well, it's rolled out on 5 zones, But you mean two masters as idle available? Or
No, I mean just a normal VM running its own Icinga and responsible for its own checks and reporting the results to the master cluster, like you use NRPE, just in a
yeah, so if you define it as a zone master and then run itself as a check, yeah, it could be extended quite easily. I didn't think of that, but yeah, most probably if you show me exactly what you mean by it, I can get it in there quite quickly. It's not that complicated, but at the moment I've always used NRPE and the old version of NSCA. I saw that you have your own version. I was checking last week. The NG version. So I've not yet played around with the NG version, but I never thought about using Icinga as a client itself and monitoring, well, and reporting back to the master. Any other questions?
Thank you very much for your talk, Tosh.